Okay, in this video tutorial, I'm going to briefly go over the in-class activity from the Simple Machines lecture. So the first question you were asked was about this ramp. And it was asked how much effort force is required for an 80 kilogram wheelchair-bound person to roll up the ramp shown below. So the first thing that I'm going to do is I'm going to go ahead and write down everything that I know. So I know that we have a mass of 80 kilograms. So we write down 80 kilograms. And then I also know that I have a distance effort. So the effort distance is going to be 12 meters. And the distance resistance is going to be 2 meters. And what am I looking for? Well, I'm looking for that force required to get up there, so the effort force. And that's what I want to find. Okay, now once I've written down everything I know, I look at these and think, do I have a relationship that can relate everything? And I do. I have this relationship of the mechanical advantage. So the mechanical advantage tells me that the work in equals the work out, and it relates the distance effort to the distance resistance. And it also relates the force resistance to the force effort. But I can go ahead and calculate this distance effort, distance resistance right now. So let's go 12 meters divided by 2 meters. And I end up with 6. It's a unitless number because the meters cancel out. All right, I also know that the mechanical advantage is related to the force resistance all over the force effort. And we get this relationship because we know that the work in equals the work out. The work does not change. So now I know that this whole thing equals 6 as well. I can rearrange this equation to solve just for what I'm looking for. So I'm looking for this force effort. So my force effort is going to be equal to my force resistance all over mechanical advantage. And I can plug in what I know, except I don't have a force resistance yet. I go back up to here what I know. I have a mass, but not a force resistance. So I have to think about what a force resistance is. So in this case, the force resistance, I'm working against the force of gravity here. So this is, the force resistance is the force of gravity against this 80 kilogram wheelchair bound person. So the force of gravity, and I know that the force of gravity is mass times the acceleration due to gravity. So my mass is 80 kilograms here, and the acceleration due to gravity is approximately 10 meters per second squared. So I get the force resistance, or the force due to gravity, against this wheelchair-bound person at 800 newtons. So now I can go ahead and I can use that number down in this part of the equation. So I now know the force resistance is 800 newtons. I know my mechanical advantage from my distances, which is 6, no units. So 800 divided by 6, I get 133.33333333. This is approximately 130 newtons. So my final answer would be that it takes 130 newtons of force effort for a wheelchair-bound person to go up the ramp on the 12-meter side. Okay, so the second part of this question asks, does walking along the slope of the 12 meters change the amount of work done compared to climbing up the 2-meter height? Well, let's think about if we have a person who's up here. So we have a person standing up at the very top here. How much work was done to get him up there? Does it matter if he climbed up the side here or walked up the ramp over here? Well, what do we know about work? Well, work is just a force acting over a distance, right? And this force and distance have to both be in the same direction. So the force in the case of something when you're moving vertical, the work was done in the vertical direction. So the vertical direction is up and down like this. And the force that's acting against the vertical direction is the force of gravity. So in the case of the work that we're calculating here, this is the force of gravity. Now, the distance, since we're talking about the force of gravity, has to be also a vertical distance. So we can call this the height too. So this is the height. Do we know these things? Well, from our last exercise, we know that the force of gravity working against him was 800 newtons. And we know that the height that he's going up is 2 meters. So 800 times 2, you get 1600 newtons times meters, which is the same as joules, so 1600 joules. So that was a little beyond the answer to this question, but it tells you how much work was done against gravity to get somebody up there. And it doesn't matter if he goes up the ramp or goes up the side. He's in the same position at the end, so the amount of work that was done to get him there is also the same. So here's another question. How much potential energy does he have stored up there? Hopefully you answered 1600 joules. So this equals the work and the stored potential energy of the man at the top of this ramp.